Hello everyone and welcome to Handmade Hero Show We Code Complete Game live on stream. I have an announcement to make at the beginning of the stream here that is basically it's more or less Handmade Hero job listings. I guess is what I would say. And hopefully there's enough people out there watching to maybe help out with this. So let me give you the rundown. So a fellow I know, his name's Alex Austin. He's been a game developer for a long time. And you may know some of his games if you follow indie gaming. In fact, if you were around for the original Humble Bundle, I believe that you would probably know his work. So he did Gish, which was a game with Edmund McMillan. He did a hockey game, I think just called Hockey ? Can't remember what it's called. He did Golf for Work Groups, and he's currently, and other games too. But he also now is working on a game called Sub Rosa. And you can find this game on the web here and actually see what it's about. It's basically a game where you sort of play this. I'm trying to think of what the right way to describe it is. You are in a city and you have teams, and rather than be like a simple kind of death match or capture the flag kind of thing where the teams try to shoot each other over some objective, it's actually a game that involves a handoff. So there's at least 3 teams. One team has a disc, another team has money for the disc, and the third team has neither. And the goal is for the team with the disc to sell it to the team with the money in exchange for the money. However, in some sense, that's not really the goal either. The goal is just to get the money, really. And so there's many ways it can go down. The team with the disc can arrange a drop with the team who has the money, and you can actually do a legit exchange, and if no one gets an itchy trigger finger, it doesn't erupt into a firefight and it's fine. But the third team could always stumble in on this and start shooting and whatever. So it's kind of a game that's about taking the standard Grand Theft Auto mechanics where there's cars and people with guns, and making sort of a standard Hollywood style drop be part of it. So there's plenty of deception and saying you're going to meet someplace when you're not actually going to, or don't actually bring the cash, or doing sort of the thing where you both put it down on the ground and step away slowly. So it's an interesting take on first person shooters. It's been around a while, and it's published by Devolver Digital. And the long and short of it is he's the only programmer on the project, and he needs a second programmer on the project. So there is contract work that's going to be available for this game. And like I've said many times, it's always hard to find engine people who can do low-level code work. It's an entirely C engine, so it needs to be somebody who understands how to program things like we program on Handmade Hero. You can't be throwing templates into the mix. It's not going to work. You won't even be able to build. And so if this is something that interests you, feel free to bring it up, contact me. You can actually, at the end of the game on the chat, if you want to bring it up, or you can just mail me. People know how to contact me. Or you can find Alex Austin on Twitter and just shout directly at him. But point being, get in touch. This is him. And, you can, okay. It's got all physics-based movement in it as well, so it's kind of amusing. You can do a lot of kind of crazy things with the system. But anyway, just wanted to put the word out because, like I said, engine programmers are hard to find. The type of people who watch Handmade Hero are kind of probably the people who could help out here getting the project finished. So if that sounds like something you'd be interested in, again, I am not involved in this process whatsoever. I make no warranties about the job or vice versa. I told Alex I am not vetting anyone for it either, so I'm simply acting as someone who lets you know that job is out there, and maybe you want to see if you can get it. I know nothing about the project or its state. I don't vouch for it, and I won't vouch for you. I am totally disinterested third party, although I guess I'm interested enough to say I like Alex and wanted to help him out, so we'll say that. But I make no warranties to anybody. I just want to help get people connected, and then I trust that the two of you can figure out whether you would work well together or not. So there you go. You've got the information now, and this is obviously in the main part of the Handmade Hero video. So it will be uploaded to YouTube. If you need that contact information later, you can go get it from this episode's video on demand. Okay, so today we are going to start working with our tags file. We have a typo in there that has been noted. And so we've got to go take a look at what we've got for bugs in there. In terms of our data entry, you know, no one ever said I was great at clerical. But let me go ahead and load up the project here. And we'll load up that source art there. That is in tags. And you know, so here's another thing. Remember, I was wondering whether I should put these in a separate directory or not. So here's another thing that's actually kind of nice is that since these .hht files are here, I could auto-load them as well when we load the project by saying load everything in the tags directory in forecoder. So that's another nice reason to say that they exist in their own separate directory, because that just kind of, it just makes it a little bit easier on us. All right, so let's address these two typos that I made. Apparently I said undead. Oops, that's not what I want. Apparently I said undead and bones. Yeah, I did. And presumably I only said that in one place. And then it looks like we've got a hand that's marked instead of a head. And so let's just double check that. Yeah, so this is supposed to be a head. I don't know if we've got any other issues. Someone was saying maybe there was a missing comma in here. One of the things is that we probably don't need to worry too much about it, because once we build, which I guess is what we're starting on today, once we build something that compiles this, it should be able to report to us things like the fact that the undead word wasn't in the set of things. Oh, there's the missing comma. Or that there's no comma between things when there should be. Now, granted, I guess, to be completely honest with you, I don't know why I put a comma in there. There really isn't a need to have a comma in there, because it's not like you couldn't just interpret a space as being the thing that separated tags. So I'll be honest, maybe we just shouldn't bother having the comma in the first place, but who cares? So I think I might just leave it at the moment that way, because I just want to do that, right? I don't have another explanation for it. Okay, so what I would like to do now is I would like to make a way to load this tag file and make that be the way that we get the information that we need. There's sort of two steps to this process. Now, we could get rid of one of the steps, right? And also, ooh, that doesn't sound good. That sounds ambulance fire engine-y. I hope that's not my building. Otherwise, the stream will be cut relatively short. So there's two parts to this process. One part is parsing this file. That's relatively straightforward. You've seen me parse things before. So we should be able to do that without really encountering anything that you haven't already seen on Handmade Hero. But the other thing is that we need to be able to find these files once they're described. And there's two ways we could do that. One is that we can augment this information here with information about the complete path. So I could manually go and mark up each of these things with where it comes from. But I'd rather not do that. What I'd rather do is say, look, there's some rule for how these things are found. And once you know that rule, you can just know where to look. And we'll sort of scan the directory for that, piece of information. Now, this part may not, we may want to further say that this part is just kind of hard-coded. We could make it so that we don't really search subdirectories. We just say it has to be in base game, and then depending on which one of these it is, it'll either be in art, music, or sound. Certainly could do that. But one way or another, we're going to have to make a way to find these. And if we wanted to just search the entire directory structure, including finding them if you arbitrarily made random categorizations of things here, and then anytime you typed blackforest.01.png, it would find it or something like that. We also have to have a way of searching sort of through subdirectories, if this makes sense. So we will have to address some of these issues. We're going to have to figure out how to do a little bit better file assessment than we were doing previously, because at the very least, we need some way of loading things out of sort of a deeper nested hierarchy than we had before, because before we were just saying we just iterate over just the one directory. Okay, so in this schema, I'm going to go ahead and say that probably what I would do is if we parse this file, we can parse the file and create sort of an understanding of what the assets are. And I think we could potentially look at this process as a way of also giving us a potential for how to make placeholders for things. So for example, if I have one of these things like a block, and I give it a PNG name that doesn't exist, and I put tags in there, we could just have that thing show up in the game, and it could write out a temporary PNG that is ready to be filled in by the artist, right? Because before, we didn't really have much of a way of doing that. We would have just had to create the PNG ourselves in like GIMP or something, I guess. But this would give us a way right from the text editor also to sort of say, look, there needs to be other stuff in here, and we'll just make those, right? And so that's one thing we could do, and it seems good, because as we develop this, what's going to happen is we're going to want to have things that we need Anna to create art for, but we don't want to wait for her to make the art for us to actually put it in the game and get it working. And so this would give us also a really nice way of just stubbing that out, and then we can just hand the game to her with those placeholders that are generated sitting there, and she can just open them up and draw over them, and that's all that needs to happen, right? And so that gives us a pretty compelling way to sort of drive that process potentially. And maybe there are some details that need to get ironed out in there, but that's something we didn't really have a way to do quickly in text before. We would have had to create an actual art file. And so this is one thing we might want to think about is, can we sort of create that that opportunity to improve, what we were doing. And so I think that's a good idea, and I think what we could do is take in the art directory. We've got these template files, for example, and one of the things we could do is we could take those template files. We could draw into the template file some like placeholder garbage that's just what we'll expect to see when we don't have an asset for something that we actually want. And then we could take those template files and copy those out into, like, when we want to create a stub, we just have the game automatically copy those template files into the location that it wanted there to be a file and that there currently is not a file, right? And so that's where I'm at. And yeah, I don't think I have anything else to say about it. I think that's it. All right, so let's go ahead and get started. I'm just going to do the basic thing. I'm not going to try to do anything fancy at first, and we'll kind of just work towards getting to what I just said. If you remember, we actually already have in our project, we have a thing that does parsing, right? We have a tokenizer. And you can kind of see in here, we've got a bunch of stuff that we use to make it work. This tokenizer is was in our metaprogramming demo that we did, where we just kind of made the simple preprocessor, right, thing that it wasn't designed to actually be used on Handmade Hero. It was just something that I showed one time about how you might do metaprogramming. And so that's already there and is capable of parsing C-like stuff. And so we can just use this code and make that into a thing that actually exists inside Handmade Hero for real. And so that's what I would like to do. Now, if we look back at what's happening inside Handmade Hero, I believe, inside the asset builder, we also do have some token sort of stuff. I don't remember exactly how we were doing it, to be completely honest with you, because it's been a while since we've been programming Handmade Hero. We just got back from break. But if you remember correctly, we got this asset type stuff, and we sort of had a thing here that would, do some kind of crappy HHA, like, it's not in there. Where is the actual parse part of things? I don't actually know where it is. Let me see what we've got here. It's not in the asset builder anymore, is it? Might be in, not in handmade types, but it might be in the HHA stuff, which is in file formats. I'm not sure where we actually put this. Let me see where we call tag ID from name. It looks like it's, okay, so it's in end tags. So here's the begin tags, here's the end tags. I just want to look at how we're doing the parsing here. So there's pop token, right? So you see what I mean? We kind of got code that does this in here as well, right? And it pulls tokens off the list in a pretty undignified fashion, right? It's just a simple thing here. And so, I think what we can do is say, let's unify these, get a real tokenizer in here because we already wrote one. And then we know that we're going to be ignoring file names from now on, so we don't need this nonsense here anymore. So basically, this stuff can kind of go away, right? So that's what I want to do. So I'm going to make a handmade tokenizer here, right? And in here, we're just going to populate that by, again, going out to the simple preprocessor and saying, let's take a look at what we had in there. Now, I don't know. So it looks like here's our token stuff, right? So I'm going to pull that stuff out. And one of the things I might do is we could still leave this tokenizer in not leave tokenizer. We could still leave the metaprogramming thing in place. We could still have it work. And so we might want to do that. If we hit build at the moment, we still can build the simple preprocessor. I don't think it actually is being built at the moment. Simple preprocessor. There's the build line, and here's us running it. So let me go ahead and build it. You can see it getting built there. So I can leave it building. And I can even run it if I want to. And it produces handmade generated.h, which, to be honest with you, I assume is still sitting around here. Because probably it would be. Looks like, so did we delete it? Or is it in the build? So I'm not sure where this would have been in. This would have been in build, so it would have created it in the build directory. And I guess we just never run this on this machine. So I'm going to go ahead and run it, right, and see. Oh, that's fantastic. So this is good. We've got an old preprocessor that's kind of necrotic at this point. So let's just get that reworking, and then we'll pull the tokenizer out, and we'll share the tokenizer across those two projects. And then we'll know that we've got something that's in good shape. So let's go ahead and do an MS-dev on that and see what's going on there. So Simple Preprocessor, we'll load that up. And inside here, we'll set the properties to the extent that we need them. I don't actually know what the properties are. It looks like there aren't any. It looks like it just dumps to standard out, I guess, might be what happens. So let me see, what does it do? Oh, it just reads these file names, I guess, directly. I see. So it just couldn't find the files. So it probably just asserted. So it's probably fine if I rem out the entire thing. Yeah. So never mind. It's not actually crashy. It's actually just asserting, which is probably what it should have done anyway. So never mind. All right, so that produced handmade generated.h, and so we can look at that and verify that it's actually building something reasonable. So here's handmade generated.h. Let's see if it's got anything in it. Okay, so it doesn't have anything in it. That may be intentional because, again, handmade, the simple preprocessor was looking for particular tokens to signify that something should be read. And I think we got rid of those. So let's just add one back in synthetically at the moment. Just to make sure that this thing still works. So in here, let's see. What's our keyword? It's called introspect. And I'm loading like sim region. So like if I go into sim region .h, if I just put like introspect in here in a couple of these places, then I should get something. I guess introspect needed like a group. So, maybe I'll just say this is the sim region introspection code or something like that. Let's just say. And so now if I look at that generated code, if I reload this, hopefully I get something. So I didn't get anything. So that makes me think that this is slightly busted, although it did give us an error. So it's at least parsing this. When it said parse struct tokenizer, it looks like it would have just printf'd directly in here, right? So I'm not 100% certain what's wrong there. So maybe I will MS-dev that and just see what happens. So I guess I have to set the directory, and I guess that handmade generated. Oh, you know what the problem was? The handmade generated does get created in here, because this is where it actually did the build. So the fact that I ran it in the wrong directory before was the only reason that it generated this file. So I actually don't want to look at that one. So maybe it actually is fine. So if I look in the current handmade code directory for handmade generated and just look at it, so there, okay. So it totally is still generating everything just fine. And, off we go. So that's all fine. So our introspection code is just fine and does exactly what we think it should do. And so let's go ahead and verify that we can make the tokenizer work sort of separate from that, right? So if in here I want to do a comparison, I can take handmade generated, and what I'm going to do is I'm going to take this H file that I know is what I expect this thing to output using the tokenizer as it was originally intended, and I'm just going to rename it to handmade generated original, and that way I can run a diff against them and see what the difference is between that one and a new one. So for example, if I run the code again, it'll generate the handmade generated. And now what I can do is, I don't know if I have a diff program installed in this machine. I do. So this is Meld. I don't know if we've ever used this on stream before, but basically Meld is just a program you can download for free. If you've never seen a diff utility before, then you won't be familiar with it. But if you ever have, then you know what this is. Essentially what it lets you do is load two files or two directories or various other things and say, show me the differences between them. So you can download it from here at Meld Merge. There's a Get It button, and you can get it. And then here's the two buttons. This is the Windows version that we're using. I think we might not be on 3.2, but we're something along those lines. And so if I go ahead and open up Meld and say, look, could you please grab W handmade code handmade generated.h. Here's the original. Here is the new one, right? So it's the original versus the new one. And then I say compare. What I should be able to do now is I should be able to, let me see. I don't know if there's a refresh button. I would hope that there was, but there might not be. Okay, so F5 does refresh. So what I'm going to do is, let's suppose that I broke the tokenizer, right? So in here, when it's going to look for, I don't know, when it's going to look for pointer, it's gone. So it'll never say that there's a pointer, or better yet, it just says that the pointer is like an identifier or something, right? So it's just busted. Now when I run it and I hit F5, I want to see it break, right? For some reason, oh, there we go. So it's asking me to reload. I say yes. And so now I can see that it's not producing the correct results. So this basically allows me to set up a standing test to verify that what I think should be happening with the tokenizer is happening. And so that will allow me to check to make sure that I haven't broken it as we go. So again, just takes a couple seconds to set that up. It's an easy test to get, so I might as well get it. All right, so inside Handmade code, I'm going to open up handmade tokenizer.h. I already created it, but I guess I didn't save it to a file. And so what I want to do now is I just want to put the sort of the base information that you actually need for the tokenizer in here. And I need to grab like the support for the tokenizer, which is this stuff. And I need to put that into the C file, the corresponding C file. So I'm just pulling these out of the simple preprocessor, and I'm putting them into this separate code that I will include in both places. So now in here, where I've got the simple preprocessor, now I'm just going to want it to say, okay, you can go ahead and grab the handmade tokenizer and use that instead of having to implement your own. And that way both programs can share it. So I'm going to go ahead and compile it. And I think what's the problem here? Handmade tokenizer.h. Isn't there a handmade tokenizer.h? It's right there. What's the problem? Is it not in the right place? So it turns out I put neither of those in the right place. Where did I put them? Probably in the build directory, huh? Where did they go? I need some way of in ForCoder to say where stuff is better. I get confused about that a lot, and I don't necessarily know where things go when they're created. Once they're created, I don't have to care. So here we are. It created them in the tags directory because that's where I happened to be at the time. Yeah. Not what I wanted. There we go. So ignoring that slight inconvenience. Okay. So the simple preprocessor just gets compiled again, and you know it should be, like I said here, it should just be identical because I haven't done anything yet, right? And so the first thing I want to do is I don't want the tokenizer to be working on C strings. I want it to be working on length style strings. And so, you know, you can see that the tokens themselves already have this structure. They already have a text length and a text. So really, the only problem is that the tokenizer itself does not work that way. So the tokenizer is based on null terminated strings. So the tokens I can trivially convert to strings very easily. It's just going to be the tokenizer checking that actually needs to get improved. Okay, so what I need to do here is I need to look at the definition of string. You can see here that it's just a buffer, and a buffer is just a count in data, right? And so what I need to do is I need to sort of import this as something that's going to happen into my code here. And so I sort of need this to include Handmade shared, which means that the simple preprocessor wants that information, right? So in here, I'm going to try to do that. Here's handmade shared.h, and I probably will need some other things, like it probably needs like handmade platform.h, probably. Not sure. So let's take a look at what it's complaining about there for v4s. And in fact, now that I think about it, really that buffer stuff should probably be in the platform part because that's just sort of a fundamental type. We could actually just put it in here. Now I think about it. Yeah, in fact, that is handmade types. Why did I think I needed handmade shared? Good question, Casey. So if I get handmade types, then I can get the tokenizer, and that would allow me to say, look, there's a string in here that's just the value of the token, right? And then I should be able to basically port the code forward without doing much work, just looping through the errors here that I have and fixing those. So like I said, in here, if we look at the type, it's just count in data. So anywhere there was a text length is now just going to be like, you know, text length is going to be value.count, right? And really, it's just a straight replacement, and then it should work. So then the only question is, well, what about text, which is this one? That one's a little bit more difficult because, again, it's a U8 pointer because we don't really use char pointers in Handmade Hero. But no big deal, right? It's still something that we can handle pretty easily. So a .text is really going to be a .value.data, right? And then we'll compile again. So then at that point, really all we have to worry about, you can see, well, there's really not many. So it's very, very few, right? So other than the ones that are in the preprocessor, which we'll deal with in a second, you can kind of see that we have very, very few things here that we actually need to fix, and they're all exactly the same thing. They are because the tokenizer itself is still using a null terminated string, right? Okay. So I'm going to kind of cheese this out for a minute here and say I'm going to cast these to U8s, knowing full well that pretty soon well, in fact, I might even do this. So we can just see this in a second and remove it because I don't actually want it there in the long in the eventual system. It will get removed. So I want to. Oh, don't ask me why I put a parentheses around that, which was not at all necessary. And so now, if you look, there are no more errors in the actual tokenizer. So the tokenizer itself is self-contained and uses the string. The only difference that we're getting errors from now is that the preprocessor, which uses the tokenizer, that is not. So if we look at where that's happening, you can see it's mostly when it goes to try and print things out. You can see that it's grabbing those things here and having trouble, right? But again, same text replacement will work here. So where I was saying .text length before, .value.count will suffice pretty much for everything. No big deal there, right? And the same is true for text. So everywhere that I was saying .text, I can do .value.data. Lovely. And so now, of course, we can check and say, make sure they're still identical. They should be, because we haven't really done anything. We just changed a little tiny bit of it. But now let's take that one extra step and say, okay, the tokenizer itself is going to need to operate on strings, not char stars. So what I need to do now is sort of change the way in which that tokenizer was operating, which will involve some significant changes, because while some of the things like these comparisons will be just fine, some of the other things will not be, because there will be issues regarding how, excuse me, regarding how they check for the end of the stream. So that's really what we got to look at here. Okay, so looking back at the tokenizer, we want this to take a string. Before I do that, actually, let me just go ahead and turn this into Handmade Hero internal style. We'll turn those inlines into internals, and we'll turn these bools into B32Xs, just so we're more in line with the way that we tend to mark things up in the code. Similarly, where I've got those ints, I'll probably fix those as well. Let me do that as I go through it, though. It's not very much code here. It won't take very long. Okay, so we've got this stuff, is end of line, is white space, and so on. And what I'm curious about is, do we have multiples, right? And what you can see right here is we absolutely do. We've got two different versions of is white space because, hey, unsurprisingly, we had to do that before. And so we have a version of is white space that's happening inside some of the shared code here. And that's something that multiple people were using. We've got string hash of and so on. And so you can kind of get the sense that these sorts of things already are happening elsewhere. And so I don't really want that to occur. Also, I kind of want to do this in here too. This stuff should all be... I should really not have inline anywhere. We don't really need inline as a thing. I don't know why we've got it. It doesn't really do anything. So anyway, let's just look at making sure that we don't have duplicates here. This stuff is all in the shared code, I believe. And again, you can kind of see that it's in here. We've got like mostly string sorts of stuff. You can see that there's just a lot of string-based stuff in here. So what file is this actually? I don't actually know which file this is. It is Handmade shared. So the interesting thing about Handmade shared, like looking at it, is that it's almost all string utilities. It's like all string memory utilities, which is kind of odd. So yeah, and if you look at like this stuff is a little bit out of place, like getting the debug color. That's why those like v3s, v4 dependencies were in there. So what I kind of want to do is sort of delineate this code a little bit better. Let's find a place for those debug colors that makes a little bit more sense. How about, for example, in like some of the debug actual files? Like, can we just put that in here? Oops. Like, is there any downside to that is what I'm wondering. Like, could I just have done this? And does that work, right? And I don't know if that's a problem, but... So in entity and in-game editor, those aren't there. Why aren't they there? Is that because the debug.h file wasn't included? Or what? Right, because here it is. Which one are we in here? Handmade.cpp. Yeah, I'm not sure why that wouldn't be there. So debug.cpp is there, but debug.h, I guess, isn't. So we keep that included kind of out to the back. Yeah, so I'm not sure like where the best place for that to go would be, right? It's a little bit tricky to say. But I really want to split this into two because I really just don't find that to be appropriate, you know? What I might do for now is just, I might go ahead and say, let's put it in here. By the way, this is such busy work and nonsense. Like if C or U++ had ever added a proper parsing model, you wouldn't have to care where things went, right? It's kind of ludicrous that you ever have to, but that's just, you know, par for the course. So anyway, I can just put them in Handmade for now, and they can just sit there as something that people can access. But that way I don't have to worry too much about that. And then inside the preprocessor, I'll include the shared code, right? And we'll take a look at what has to happen there. Perfect. And so now I also am getting an error on those multiply defined functions, which is even better. That means I don't have to go remove them myself. I can have the compiler tell me that there are two. And so all I really want to do now is say, look at the two is end of lines. And I just want to get rid of one of them. I want to get rid of the one that's in the tokenizer and use the one that's in the shared set, but I just want to make sure that they're the same. And so theirs is white space and is end of line. So in here, I don't know if we've got an is alpha anywhere. It looks like we've only got one of those. So I would say these also should probably come out in here as things that can be used by anybody. And so then we're just left with the ones that are actual token, tokenizer based operations. And that's good. So now what I've done, again, just really tiny little baby steps that just get things into a good position. I now am running the simple preprocessor, so I know there's a test case. It's producing the correct output. I know that I've got a parser running on this tokenizer, so I know that it works. And now what I can do is make that one last change that I wanted to make. And what I want to make here is a thing that says, here is the input to the tokenizer, and it can run. Very, very straightforward, right? So let's go ahead and do that. In here where I create the tokenizer in the first place, wherever that is. Yeah. So I'm not crazy about this. The reason I'm not crazy about this is it doesn't give any structured place for initialization on the tokenizer, and I probably want something like that to happen because maybe I want to set some additional parameters or whatever. So I probably want to stop this way of doing initialization. And what I would like to do is I'd like to move to something a little bit more specific. So I'd like to be able to, oh, and let's get rid of these statics while we're at it too. What I'd like to do is move to something more like this. Hey, I'll give you the string to tokenize, you give me back the tokenizer, right? And so then I can just say, all right, the result is just going to be copying this in and returning it, but at least then I know I have a structured place where that's occurring and I can fuss with it later. And so then in here, what we'll do is we'll say, hey, let's tokenize this. We want to tokenize the file contents. But of course, the file contents are a string now, so a char star isn't going to cut it. What that also means is read entire file into memory and null terminate doesn't need to be in that anymore. It can just be read entire file into memory, and it can return a string itself, which is nice. That means I come up here, and again, this simplifies this piece of code quite nicely for us. In here, when we actually do this, we no longer need the +1. Instead, all we have to do is actually just do the read. And when we produce that result, which we malloc, right, we can now just bundle those two things up into the string result in one go. And so the way we would do that is say, oops, no, we would not leave ourselves in command mode, otherwise that happens. Instead, we would say, start with a null result. So if we return it, the person knows there's nothing in the file, or we couldn't open it, who knows. Again, this is just for the simple preprocessor, so we really don't care. But then we say, okay, the result count is going to be whatever the file size was, you tell me. The result data is going to be allocated by this handy little malloc call here. We're going to read into that piece of information based on the count into the data. And then instead of setting a null terminator, we're not going to bother because now we're returning the size. That means all of this stuff flows nicely and works exactly as it should. However, now you can see all of our parsing is busted because we changed from having a cursor-based null terminated input to having a string-based input. And now we have to go deal with that. But you can see there isn't much else that's a problem here. I accidentally here forgot to replace that result count, so that's not really something we have to address. Read entire file into memory, we've got to rename, and then tokenize we have to fix, right? It's just a R that was missing. So that's really it for the mods to the using code. Very straightforward, which is great. But now we have to go back to the tokenizer and do the more difficult work. So if we look at what's going to happen here, token equals is fine because token already was a string-like class, and it has to do this operation anyway. We probably don't have to actually use this anymore because strings are equal probably exists for a string. You can see it right here. This is the code we actually needed. So I believe that we can effectively say you don't actually need to call this. Instead, you could just do this. Because again, we already had that code. Now, in fact, and you know what? We even had it even simpler. We already have one that cracks it for you too. So it's actually that. It's that simple. So I think that becomes pretty obvious, and presumably that's all we would need to do there. This code can be eliminated as soon as I verify that everything's fine and there wasn't something strange going here I didn't think of. So that's just fine. So now we're down to the code we actually have to play with. And what you can see here is if you change from null terminated strings to length-based strings, which I highly recommend, by the way. I think length-based strings are the only real way to go. Literally everything that you ever do gets easier with length-based strings, except one thing, and it's this thing. So checking for tokens by hand is the one thing that gets harder. I don't know anything else that does. Every other piece of code usually gets easier. Not this one, right? So there you go, but that's what's going to happen. So in here, when we have to do something like eat all white space, this obviously will work just fine because what we can do is anytime we're looking at one character, we can just first say that this is while there's any left in the input. So here I can say while tokenizer input dot count, that lets me know that there is something to check in the buffer still and not nothing. That means anywhere here where I'm checking at 0 will just work. But anywhere here where I'm checking at 1 won't, right? However, I can cheat, okay? There's a pretty easy way to cheat one character look ahead, token lookups, and that's just pre-do it. So what I can say here is I can say at 0 equals tokenizer input dot data 0, and then I can say at 1 equals tokenizer input data 1. The problem is this, right? We'll crash. Well, when I say crash, but it'll read off the end of the buffer at least if the count is not greater than 1. So what I can do instead is just say, let's make sure it has to be, right? Tokenizer input count is greater than 1. Then I use this. Oops. Otherwise, I use 0, right? Now, all of this code just kind of works because all I have to do is just look at the two pre-prepared values I have, and everyone's happy, right? No big deal. However, we now have the problem of how do we advance. I probably really shouldn't have done all that removal, by the way, because I'm kind of doing illustrated point, but we're about to do another change that will probably make it not be so good. Right? So how do I advance now? Because, you know, I need to move this forward, and so like all these statements have to have move something forward, and these things won't get updated properly if I update it and then check them again, right? So in addition to being able to update it each time through the loop, I have to be able to update it maybe more frequently, like right here or right here, right? Well, as you might expect, I can just make this be more systematic. I can make the tokenizer itself have its read-ahead buffer actually be something that's updated out of the regular buffer, right? Now, again, maybe this is a little bit of a cheating kind of thing. I don't know how you want to look at it. I just find it to be kind of convenient, right? So what I can do here is say, okay, suppose we left it the way it was and just said, look, let's actually make there be a thing in here that is char* at, but maybe it's not really at because I want to go through the code and change it so that we're not ever incrementing that pointer or something, right? So we'll call it something else, which is just like, you know, A, and there's two of them or something, right? Then from then on, I can just have, anytime I would have been doing a plus plus, I can just call advance, and advance takes however many characters to go forward, right? So, oops, maybe something like that. Advance chars. So now, anytime I was doing this, I can just call advance chars like so. And that moves my tokenizer forwards in the same way that it used to. But I can still keep all of the checking exactly the same. Because all I have to know is what's the furthest ahead that I ever look. And I just make sure that I actually have that. Right? Make sense? I'll leave it as at for now. What the hey? Live dangerously. Pretty straightforward, right? And so then if I come down here to this code, I can do this stuff exactly the same way if I want to, right? I can say, okay, this is going to be, oops, advanced chars, tokenizer 1, right? So I do this kind of nonsense. I just say, well, I need this thing to be whatever the actual, string is that I would get. Instead of doing it that way, why not just say, you know what, the result is just going to be whatever the input was. And then, you know, if the count was valid at all, it's 1. So it'll either be 0 or 1 based on what we have. So we initialize this basically the same way. Oops. But we do a little check there. And so then we say, all right, grab that C out and then advance 1. So we're just going to eat 1 character. I don't know that that's the best way to do this, but that's how we were doing it. So we'll just stick with that for now. All this stuff just works if it wants to read 1 token. If it doesn't want to read 1 token, then it has to do this sort of thing. And that's fine too, right? So again, we can kind of do the exact same thing that we were doing before. So at this point, we can just say that the token value is going to be the tokenizer input. That just works. And it just has the wrong count. So then all we have to do is actually get the count correct. So as we do this, I'll do advanced chars, advanced chars. And in here, where we're doing this difference, this difference will now work properly. So I can just say, look, the input dot data minus the value dot data. That gives me the correct count for my token. And we're done, right? So that should work as well. In here, all of this stuff should still work. And you can see that nowhere in here have we ever looked past that second character either, right? So we believe, or we don't have any reason to believe that that won't just be fine. Off we go. We do need our parse number in here, so we should probably re-enable this, but we'll cross that bridge in a second here. And then we're good. So now we've got the rest of this code doesn't care really at all how these things are going, right? Okay, so what I want to do now is I need something here. And so what I want to do is every time you're going to do this advanced chars thing, I need to make that actually work. And so I need something up here that's going to let me do that motion, right? So let me go ahead and spec that in here. So if I pass a tokenizer and then I pass the the count here that I'm trying to go forwards, then what I want to do is I have fundamentally two cases. On the one hand, I've got the case where the count is some amount that I could move forwards, and the other case I have one where it would extend past the end of the buffer, right? And so what I want to do is say, take the tokenizer input. I know that has a count. If my count is greater than the count of that thing, right, then I want to clamp it. And then at the end, I want to do a move forward by that amount. And then I also want to reflect the fact that there isn't, I move it forwards and go, right? Now, that's an operation that we would normally have, just advancing a string. And so I think we already have it, right? I wanted to sketch it in there because, I wanted to explain what was going on there. But you can see here, we already have a thing that does that exact operation, right? Look at this. It's the same code, right? Furthermore, it will return, I guess it will return the part of the data that it consumed as sort of a separate chunk, which in this case, I guess we don't really need, but there you go. So instead of even bothering with any of this, I can actually just say, look, advance this by that, and that's the end of it, right? So that's even easier because now I don't even have to implement that part of the code. So then the last part of the code I need is I need to be able to have that at array actually work. So I need a way of saying after I've moved, please refill the at buffer. So at 0 needs to equal something and at 1 needs to equal something, right? And so please do that. And if I structure it so that I've got two of those, it means that I can also just call that same thing here so that I don't have to treat startup separately from moving forwards, right? So I'm going to go ahead and do that here and just say, look, I've got three cases and so I'm just going to handle all three, right? Because why not? So the cases I have is I have the case where the tokenizer value count equals 0. I have the case, where it equals 1, and I have everything else. In the case where it's anything else, then it just works, right? No issues. In the case where I only have one, then I can set the first one, but the second one can't be. And if I have neither, then I can set neither. Right? Oh, and don't ask me why I typed value when it's not value, it's input. All right, so moving on, let's see what we've messed up. You can kind of see here that for some reason I don't know why I did that. What I actually meant to do was that. I was trying to assign the value there, not the rest of it. So when we do this advanced chars bit here, I forgot my comma. Looks like that's about it. And so now we have a parser, tokenizer that's running using fixed length strings instead of null terminated. Now we don't know if it works. It didn't crash, but we don't know if it works. Let's check. The files are identical, so it looks like it did correctly produce the same results. So hopefully that's mostly correct. Now, we didn't parse numbers. We should. Let's go ahead and parse one of these numbers here. So what I'd like to do if we're going to parse a number, I think we already have this, right? We in the shared code, there was a way to parse like an ASCII thing, like S32 from Z, right, and stuff. So we've got these here, right? So we can parse numbers. Well, actually, you know what? Do I care about parsing numbers? You know, I probably do, but I'm going to hold off on that because I guess we can implement everything we were going to implement today or, you know, for the next couple of days without it. So I guess why complicate matters. So now I have a tokenizer that I can use to, you know, grab all of that data that we were creating in those tags files. So, you know, in one of these guys here where we've got this thing, if now I just want to parse that thing, I should now be able to do that. Now, looking at it, there's a couple things that I'm going to have to augment my tokenizer to handle. So let's just do a little audit and say, what do we got to add? So you look in here and you say, well, we've got some identifiers. Those will just work. We've got strings. Those will just work. Braces, semicolons equals commas. Braces, semicolons. We don't have equals and we don't have comma, right? So let's just start by adding. Go into the tokenizer. It's pretty trivial. We can add any single character things we want, you know, with no effort. So that's good. And then we just need to know, do we support comments properly? And since eat all white space will skip the commas, as far as I can tell, we don't have to worry about the fact that this is up there. So should be able to parse this whole thing, right? No issue. So let's say we just go into the asset import stuff. And this probably needs to get broken out at this point into like an asset import versus the asset loading. But, you know, one thing at a time. So let's suppose we do have some code here and we just want to parse one of these things and say, you know, read the whole thing. Let's verify that we can do that, right? So let's suppose we have a parse HHT, I believe is what it's called, right? And if I want to try and test this outside of Handmade Hero, maybe it makes sense for me to just put this, you know, I mean, I could even put this in the preprocessor, right? But anyway, let's just try to make this be something. And you know what? Actually, let's just go for the gusto. Let's actually put this into its own like Handmade HHT or something, right? Like, I don't know. And so inside here, we'll just write the parser, and then that way we can include it anywhere we want to, and it'll just work, right? And that seems good. So how will we parse this thing? Well, it shouldn't be that hard. There's not a lot of constructs in this thing. So what we'll say is, look, you want to parse an HHT, great. Give us the input, right? Just give us the thing. And furthermore, I could just say, look, let's even just say that you give me the tokenizer. So you've prepared it, and you're just going to pass me it, and I'm going to assume that you've prepared a tokenizer that I can get tokens from. And I don't care how you got it into that state, just make sure it works, right? And so let's do that. If we want to parse this thing, then all we have to do is say start by grabbing tokens off the stream. So, here's the token from the tokenizer. Look at the type of the token, right, as you do. And in this case, I could do a switch here, but really I don't need to, because we only support one thing, right? If the token is not an identifier, it doesn't matter, right? Anything that's not an identifier at the root, we don't handle. So, this is the end of parsing right here. And we can choose to issue an error or not, based on whether or not it's actually the end. So one way to look at it would be, well, if token end of stream happened, that's great, because that means that was the end of the file, so we do want to break. But otherwise, we could say, look, there's an error in that case, right? And that brings up another thing that we want to do, which is have some way of handling how errors work, right? That's something we'd want to do. So we'll talk about that in a second. Assuming we get an identifier, then we just want to do some way of like parse top level block, right? And we'd pass the tokenizer down, and we'd pass whatever the type of the thing was, like whatever that top level block type was, right? And so then we'd start here, and we'd say, okay, we're going to parse top level block. That's all well and good. In the token that we passed down here, this is now going to have to look to see what kind of token that was. So of the token types it could be, we only have a known set. So we're basically going to do something like this. And this would be an unknown type of top level block. Right? So in here when I have like token equals, and so on, we know what those are going to be. So it's going to be default, right? Block, and then some host of other things that we've got. So body, character, hand, cover, head, oops, item, obstacles, and that's it. That's all we've got so far, right? So each of these we would have some kind of parsing for, and we'll kind of figure out how we want to do that later on. And we may want to roll these into an array as well. We'll kind of see how we want to do that in a second. But assuming that we want to parse one of those, we would parse it, and we'd parse the block up till the closing semicolon and then return it, right? And that's all we would have to do. I should call this block type or block token. So let's see what we've got with respect to that information. Like, what do we have for the file formats? Like, do we know what those different types of things are? Because we probably don't, actually, right? In terms of the parsable things, but maybe we do. So I'm going to go into Handmade asset and see like where is character as a string, right? And so you can see it here. It's kind of doing this breakout here where it's got the the different pieces of like tag information that it's kind of generating off of the fact that it knows what the blockhead body, all that stuff. This is basically what we're going to do. So in some sense, we could go ahead and pull this code into here because this is literally exactly what we're going to do. And the begin tags, end tags part of this itself is also exactly what we're going to do. Because exactly which tags are in here, that's what's going to get added to the tag set, right? So it depends also on whether we want to do an intermediary, like whether we want to create a standing data structure for this or not, or whether we want to weld it in directly into this code because this is the only thing that it really needs to do. And I don't know the answer to that question, unfortunately. That's a little harder to say, I'm gonna kind of put a pause on that thought pattern right now. But this is basically all we're doing, right? Is just this. So, assuming that we stick with that, right? All of these things are then going to have a parse where they then, get the tags and other things that might be associated with them. And if we go back to the way the HHT works, you can kind of see that, it has like an author and description. Those can appear here. And then it has tags. Those are the three things we know about so far. But we actually have some other things that are going to happen as well. So remember, we've got align points. And so if we want to go look at what's going to happen there, we're going to need to store this information as well in here. So the p% size and type, that's going to have to be stored in there along with, like it just says right there, these are generally imported from the text file augmentation of the PNG, right? And so we're going to have to store that data in here too. We don't actually know what that looks like yet, but it's just any textual representation of this. So it's got to have these, it's got to have the scaling value, and it's got to have the alignment % value. And those can just be represented by floating point numbers. So that's the time when I'll have to add the actual number parser into the mix, because it's got to be able to be read from this file as it goes. Oh, yeah. I did not get much sleep last night. All right, so working through that, I think all of these things, basically this head part is really more of like a piece of type information, this head, obstacles, default, block, that sort of stuff, right? And so what I'm thinking is I think we kind of want to just table drive that, probably, and go from there. So I think what I'd like to do is say, block type, here are my block types. And since really that's just something that lets you know what the default tag set should be, I can just store the default tag set somewhere and leave it at that. So the table driving should be fine. I don't think we need to, deal with anything more complicated. So then I can just do, block type index, and for each one of the block types that we've got, then I can do an if, oops, token equals, and say the block type index. These are actually in the wrong order. Go ahead and check if they are, great. If they aren't, no big deal. And then, you know, it's an error if we never found one. And so for now, I'll just do like a found equals false, and here I'll do a found equals true. And then we'll just say if found, else, you know, error. And once we've got that, then what I want to do is say, well, if we found one, then we kind of need to actually parse the remaining components of the block. So if I go into this HHT here, I want to be able to grab the rest of this stuff. So at that part, I kind of need to do a thing that's like going to get each of those pieces. I need to know what the file name is, so I need to do a get token there. And what you'll see if I create this code is you can see a pattern emerges. I need to do, you know, an open brace, right? I need to do sort of like parse all the fields here. And then I need to do a like close brace and a semicolon, right? And now in order to give errors when something doesn't work, I need to be able to guarantee that this is the case. So I would be sitting around doing stuff like, well, all right, let's, you know, make sure this like string is here or whatever. Let me get what that's called. Oops, not my intention. I want tokenizer.h. There we go. So in here, I'm like, yeah, okay, so there's got to be a token string, and there's got to be, you know, an open brace. And then, you know, if not, then there's an error. But, oh, wait, you know, then I'm not really saying which one was the error, right? So I'd really need to do it like this. In order to report that error nicely, right? And you can kind of see how that gets fairly tedious. And I need to do that for all of these. It's not very satisfying to keep doing that reporting. And so what I'd rather do is just have there be an understanding that there's a concept inside the tokenizer that when I want only one particular type of token. Oh, and we already have it. That I can just ask for just that type of token, right? And so that way I can do a require token. I don't know why it returns a bool. It shouldn't. It should return the token. So that's just unfortunate, right? So what this should really do is say, that, right? And then it should return the token in question. That's what should be going on. Unfortunately, that wasn't what's going on, but there you go. Now I do have to then look back at my preprocessor and see how was required token being used here, right? Yeah, you can kind of see it was being used in these cases here, where it was like trying to open the if block. And that's probably not what I want to do, right? Like, I mean, you can do it that way. If we were going to do it that way, you would have to at least have a way to point to the thing that you wanted to actually get. So, but it opens a valid question, right? And it's the other aspect of this. So once we start getting into the mix, you can see that two things become clearer. One is we'd like to be able to do stuff like this with this sort of syntax. Right? So I want to be able to do, oops, that's not what I wanted. Right? So I want something that looks like that. I want to be able to not have to do this, and I would like to know at various points in time whether I should even bother. So I might want to be able to do something like this and go. That would allow me to do stuff like require a bunch of tokens and then just do one check. Look, are we still parsing or did we hit an error condition? And then don't keep trying afterwards, right? Furthermore, it would let me do this in these loops so that if there's an error, they don't just loop forever on the error if you forgot to put a case. They stop looping when they hit an error, right? So you can see how you can start to build up the tokenizer into a thing that sort of has more utility than just getting the tokens. You can also put into there some error handling, right? So I can have here a thing that's like error, you know? And I can also have a thing in here that stores those errors for me if I want to. So, you know, I can have a thing that's like struct, you know, tokenizer error or whatever, right? But since I think we already have the notion of an error stream, I think I'll probably just link those up together. We'll look at that in a second. But the long and short of it is what I want to have is I want to have, therefore, a thing that's like, hey, there's an error call on the tokenizer, right? And it allows me to pass some message that says what's wrong. Furthermore, I'd like to be able to pass the token in question. So whatever the token was that caused the error at the point that I know about it, I'd like to be able to specify that because it might be some token from further back in the stream, and I don't want to report an error on a token that isn't actually the correct one, right? So what this would do at a very minimum is set the error to true, but beyond that, it'll be like to do like hook up to an error stream, right? So pretty easy here, and now what we can do is say, all right, when we get a required token, and in here I can just say, look, when I got this token that you asked me to get, it was not the kind I expected it to be, right? And we can get better error messages later if we need them by doing more work here. But at the moment, this at least tells us exactly what we need to know, which is what caused the error, right? Okay. So that's pretty straightforward. And now this code, again, becomes very simple. We can also go back to the Simple Preprocessor and make that work as well. So when you do if require token here, we can just make that, again, be an error. Now, there's a couple different things we can do. One is we could say that here, when you do the open brace, if it doesn't actually want to do a parse struct, if it doesn't actually want to raise an error, it doesn't have to. We can also retain the old behavior under a different thing, which is called optional token, right? And if you look at what happens here, you can see that we had one here that didn't produce an error message. So that can still be optional token. But here we have require token, and that we can rely on the actual error reporting to occur, right? Similarly, in here, we could require that the word is struct. So you could actually make a require identifier. I don't know that I really care about that, so we're probably not going to bother, but you can see how you could start, continue to lever those things up until you had a pretty capable little utility there. Okay, so I'm going to go ahead and put that optional token part in as well. So here we've got require token. We're also going to have that same call that we had before. I probably just kept it and I could have renamed it, but I just wasn't thinking at the time. So here we just say, look, if the token equals the desired type, then it's the right thing, right? And we just never issue an error. So that's just saying, look, here's an optional token. If it ends up being this type, get a token. If it's that type, go. Tell me true. Otherwise, don't. So we can still retain that functionality, just call it something else. Okay, so in here we can say that there was an unexpected token again. So pretty easy. On this token, we just say, unexpected top level token, whatever. And in here, same thing, like anything that was happening here, parse level, top level block, we do token equals. If we found one, otherwise here we can say, yeah, that block type that you passed down, I don't recognize that, right? Unrecognized block type. You know what I'm saying? So off we go with that. And then in here, we now have the way to do this checking. We want that parsing check to occur. And so the way we're going to do that, again, is very, very straightforward. In here, we just have a B32 that says, hey, tell me if I'm parsing or not. All that has to do is say result equals tokenizer error, right? If that's not set, we're going. Done deal, right? So in here, same thing. We can come in here, parse all of the fields that we have, like so. We don't have to report an error because we know it would have already got reported. And then we know that we have to require a particular way of closing the tokenizer here. And so we expect to see the close brace and the semicolon, right? So that's all we really need to do to get the basic parsing flow going. Now what we need is some of the more specialized stuff that has to do with what's actually inside these files, right? But we're basically good to go. Let me handle that one error there. Yeah, so this one doesn't have to do an if here. This one can actually, you know, if we wanted to do it, we would just say it like this. But I don't even know if we needed to do that. If we could have structured this a little bit differently if we want to. Let's just verify that that still works, though, because we've replaced those. Let's verify that it still produces the correct results, because we may have made a subtle error there or something. But that's fine. Okay. All right, so the require token stuff should presumably be fine. In here, we've got the case where we found a block that is one of the types that we want. And so now let's just make sure that we can parse the actual contents of that block. And looking in here, there's only 3 things that it can actually be. So when we actually now, inside here, do our loop, remember, we're going to parse as many of these as occur in the block. So actually, we can do this, you know what I mean? Where we actually do a while parsing and go from there. Now, I'll take this opportunity to show you another ridiculous trick that's probably too clever for its own good, and I don't necessarily recommend it, but I can show it to you anyway. We'll get to that in a second. So let's say I go in here. Actually, you know what? I probably won't even need it now, so I won't actually show the trick, probably. But anyway. So what we're going to do now is we need everything in here to basically be, look, let's get a token. We don't know what it is. If it's going to be a close brace, right, good. We're done. Otherwise, we got work to do, right? And then I can get rid of this. So as we go through here, we can then say, all right, we then therefore expect it to be a token identifier, and we can process that. If it's neither of those 2 things, we're kind of done, right? Then that's just an error that we can't recover from because we have no idea what you're trying to say here, right? Or I guess I could say like expected field name. But instead I got this garbage. If I get an actual identifier out of it, then I can look to see what kind of identifier it actually is. Now, I could just skip this and say, look, let's just do token equals instead. And that's totally valid. We know what they are. They're author, description, and tags, right? For these 2, there really isn't much to it. We're basically just going to get a token that has to be equals. There's no other thing that's allowed there. And then it has to be a string. And then it has to be a semicolon. That's all that we get, right? And the same is true of the description here, right? That's what we have to do. And so we can get the description, and we can get the author, and we could do something with them, but of course, at the moment, we're just parsing, so we don't really have anything to do. But obviously, we're going to do something with those in the future. And then furthermore, for our tags here, we now want to be able to parse comma-separated lists, right? And so what I want to do there, again, is just open another one of these, because I can. And in here, we're just going to continue down. Now, what I would like to do is pull this out, because I don't really want to read too many nests in here. Again, just a matter of personal preference. You could just leave it in there. There's no right or wrong answer there. It makes it a little easier to read in one way to move it out. It makes it a little harder to read because now the person's got to go up there. So, you know, it's always a little imperfect in that respect. But so we have parse tag lists. We're going to pass the tokenizer and say, hey, you got to parse this tag list for me. Please do so. And so one of the things I want to do here is get rid of the equals, right? And then I'll expect you to eat up the rest of the tag list, right? And so in here again, I'm going to say, give me the token, just, you know, push it forward. And then I'm going to say, if the token is a semicolon, then we're done here. If the token is an identifier, then what I need to do is call the tag to ID call. And if it's something else, we're in trouble because there shouldn't be anything else in the tag list, right? Or expected a tag name. At that point, we just need to know if we got an identifier, we would require a token to be a comma if the next thing isn't a semicolon, right? So there's a couple different ways you can do this. A possibly smarter way than what we do it is to have a peak token call. We don't really need one here, so I'm not going to bother. So I'm just going to call this comma check, and I'm going to say get the token. And then I'm going to say like if comma check dot type equals token semicolon, then you know we're good to go. Else if comma check equals type token comma, then you know have at it. This actually has to happen here though. Sorry. Then we're fine. And I guess actually the way to put it would be if it's not a comma at that point, we've got an issue. There's a couple other ways you can do that part too. Again, all of this stuff is just, hey, when you're writing parsers by hand, there's a lot of different ways you can kind of keep things compressed and not have to type too much out. And it's really up to you which one you use and how you want to do it. Anyway, once you got that, I think we're pretty much parsing the file. I mean, that's it. So, you know, like 50 lines of code or something, and you're done. So I don't actually know exactly how we want to test this. There's a couple different ways we could do it. What I'm going to do for now is let's just get it compiling. I'm going to throw it in here as, you know, handmade HHT.cpp. The asset system is going to want to call that, which is fine. And we'll just do this. You know, I can go up to the HHT file here. I assume those are, let me see here. Yeah. Inside here, I can just say, look, this is the call to that thing. So if you want to call it, you know, be my guest. And now at least we can compile it and go get rid of the obvious compilers, stuff like that, right? So let's see what the bugs are here. We've got illegal use of type. Oh, don't ask me why I did that. I don't know. All right, so the tokenizer is undeclared to identifier, right? That's because we have not yet put the tokenizer in here. So in addition, we're going to have to put that guy in there. And that should probably be moved up a little further because that's going to be more of a utility guy. So he's going to be done. It's going to be used by probably more people than just the HHT, I would imagine, but who knows. I'm awesome at typing those two letters in order, apparently. So let's go ahead and take a look at some of these. So you can kind of see here now we've got the conflict. And this is good, because now we're talking about merging these two code paths in a sense. Now, we don't really care because this code path's going away. I could just nuke this code path and be done with it. But, you know, why not just take this part of the code and make it work in both cases, right? There's no reason not to. And so what I'm going to do here is just say, all right, in the tokenizer case, I kind of think, yeah, maybe my past self was smarter than my future self. Maybe this should be called text, not value. Why do I think that? Because the text is different than the value, right? And so I might say that this is a little bit more how that should go. Maybe you want something more like this, right? Where you got a couple of different value types that can happen, like an F32 or an S32 value type on the token. So let's go ahead and move forward with that as more of the idea for how this is going to work, right? And so for these, wherever you saw result.value before, so here.value is going to have to become .f32. And that's all fine. You can see that really wasn't much of a thing. So whatever, that didn't really happen in very many places. But now we're going to have to do is kind of retcon that back and pretend we knew what we were doing over here. So everywhere that we saw something like token.value, that's going to have to be token.text, right? And so that's unfortunate, but again, we screwed up. If you screwed up, you screw up. I'm behind my head. I can't even see what that last one was. Okay, there we go. That's fine. So again, same thing here. So value.count is going to have to be text.count, right? Just fix all those. And similarly here, value.data. Going to have to be text.data. And so we're just kind of cleaning up that, worse naming using the better one. All right. So here, for some reason, I did require, I meant tokenizer. I typed it wrong there. So let's just go ahead and fix those. And get these two things merged. So what else we got there? Looks like error is busted in that one. I just missed one of these. What is the problem exactly? Oh, block type is not a thing. This is supposed to be block token. That's just a naming fail. I think that's about it. So now we release to debug the parsing process, and then we have the ingest done, and we have to decide how we want to actually interface it with the main asset system, right? And that's kind of a little bit of a boundary value problem. You got to think about both sides, like how do we want this to hook up, and do we need this parser to operate anywhere else, or can it just literally operate in that one place, and I'm not sure, right? So I think that's all we really need to do here. Let's go ahead and try calling it just as a simple matter of course on something and see whether or not we can get a reasonable result. So what I'm gonna do, because I feel like it, is I'm gonna go into the Simple Preprocessor here and or maybe HHA edit and just say let's call it from there because it's easier. So inside HHA edit, I think I've got like read entire file, right? Here it is. And so like looking at how this code works, I'm thinking maybe I can just drop a thing in here that does like a parse. And maybe we just make that happen, right? So just to give you some, just to give you a little background on what I'm talking about here. So what if I just added a thing here that's like, all right, yeah, like if args one, instead of minus create is like minus, I don't know, check HHT. Who knows, right? This would be something that just runs the parser and then prints out the error messages, right? And just because I want a convenient way to run this and test it. And so, it would do this exact thing here. It would load that file in, and it would have to exist. We would read it in its entirety. In fact, I really just want the read entire file. Does anyone actually call that? Yes. So what is it loading there? The source file. Interesting. So in read HHA, it calls that, but other people don't use it or something. All right, who cares? Anyway, so if I was going to do this, I just say, all right, get that for me. I'm going to say read entire file. And off you go. I don't care about any of this. If I can't find it, I say that. And then here I'll just do tokenizer equals tokenize. I'm going to pretend this returns a string. And then I'm going to call parse HHT. So this probably needs to be a little bit more robust than that, but I don't know, maybe we don't care super much. We could look at that a little bit later. But now if I did this, that would give me what I want, which is a way to run this a little bit more straightforwardly and simply, right? If I go back to read entire file, and I could trivially say that this returns a string. I can trivially say that the HHA edit, which already includes these things, can call that. And so I can also say in here too that, handmade tokenizer.h and handmade hht.h are both in there because I already have worked all that out. So good news, everyone, right? So all that stuff is just there. In here we do read entire file. Like I said, this is kind of the same thing. So if I just go to the preprocessor, the one I already had, this thing, is basically the same, but it uses this file handle, like assuming that you've already opened it, So really, it's just this code again, exactly this code again. And so I should be able to just do that here, right? Like that. And you can see that this code is exactly the same. Oops. So that's all good. And this code is also exactly the same. So there you go. So if we do the read entire file on that, then we've got that ability to call that trivially. And then in here, where we call read entire file, the fact that that's calling on data store doesn't matter. We can just say that, and it still would work. So we have the ability to load it this way here. We need to do the open file, so we do need this, and that is good actually because that allows us to check for the error, which is what we wanted to do. So here we can do this and print out the error message if we can't find it. So can't open file, and then here we'll get the file out. We can load it in, and then we can close it. Not that it matters because it's not a big deal. So dest in this case is actually source, because we're not doing anything to the file. All right, so that should work. Let's see, I've got an issue somewhere here. I was missing a open paren. There we go. And let's see, so can't convert argument. Oh, I'm supposed to pass the tokenizer. So I think that does it. And now we could, if we want to, just run this code. And I should probably also, at some point, nuke the introspection markers. But anyway, so once I've got that under control, I should be able to call check HHT, which means I can step through the code in the debugger and see what actually happens. So if I go into here and say, all right, let's load up HHA edit, which it looks like we don't have in here. So let me actually call it msdev w build HHA edit .exe. So if I set the properties on this guy and set the parameters to like -check HHT, and I say, we'll start with a simple one, intro cutscene.hht. Yeah. So we'll start with a simple one and try to run that. So let's just step in there and see. And then we'll save for next week the issue of how to integrate things and how to debug this a little bit more further, right? So let's try to open it. We're going to read the entire file. We'll look at what the contents are, or we try to. Let's see here. All right. Chances are that is because we are not building in debug mode. And of course, Visual Studio can never find the results of anything if you're not in debug mode. Might as well not even be there. All right, so let's go ahead and run. Let's go ahead and run. Here we are loading the contents. There looks pretty good. We're going to the Tokenizer. Let's look at that refill, make sure that works okay. Should work fine. And so, if we look at the state of the Tokenizer here, you can see loading those first two characters in, setting the error to nothing. So then we go into the parse HHT. We say, let's see what we've got. We immediately get a token back, and that token is Pleat, right? 5, and there's the pointer. So we go to parse top level block. Oh, we didn't put Pleat in there, right? We don't have Pleat yet. We got to put Pleat in there. I didn't check that one. So we do want Pleat as a valid top level block. There we go. And so let's try that one more time. I'll set a breakpoint here. Okay. So after initializing this, I guess I'll run to here. We're going to loop through and see if we find anything. I'll skip to the exciting conclusion. Find is true, or found is true, so we did find it. We then have to require that this thing is a string. Did we get back a string? Turns out we did. Everyone's happy. So then we can continue parsing. We get the token back. We look at what it is. It says it's a close brace. Why do I not believe you? Is that actually true? Where's the actual contents of this file? Am I missing something? Parse HHT. Here's the file contents. So this is what I expected to see in that file, right? Where is it? Where is that data? I'm so confused right now. Okay. Does someone want to tell me what's going on? Is this just a for coder thing or something? So if I were to open another for coder and go to tags intro cutscene, it wouldn't show up. If I was to open Notepad, would it show up? Asking for a friend. Well, I don't know. That's a weird for coder thing. I'm creeped out. I don't know what's happening there. So we'll have to look into that as a separate thing. But the good news is our parser worked. Because it actually is a close brace is the next thing. So it broke out of this. And it requires a token semicolon. I don't think there was one, actually. So it sets an error, which is correct. And we would have had an error that there was expected semicolon. We then break out and we're done, right? So I might set a breakpoint at the error function and say, let's run to there. It should be an error, and the error is that there was a missing sound. The error was that there was unexpected token type because expected a semicolon didn't get one. And so that's correct. Let's try loading the more difficult one and see where that gets to. So here's our base game HHT, and we'll run that. We get an error. What's the error? Unexpected token type. Where are we on that? We're on, interesting. So we're on the open brace for default. Oh, yeah, that's actually true. So we actually have another type here that we didn't think of, which is that when it's default, it doesn't need a name. So really what we need to do here is handle default separately, and it doesn't need a file name in that case, right? So that's actually kind of tricky. So we actually have a token file name, and you know, I don't know how exactly we want to do that, but here's one way. We could do a require token here. And so we would do something like this. And we'd probably do some other things here, like set up where we were writing to or whatever, right? But so that's important, actually. So we had forgotten that defaults don't have a file name. So that's a good one. And so now the entire file parses properly, looks like, right? So hey, good job. We wrote a parser for HHT. Good to go. Next weekend, we can just use that data that we just parsed, and off we go. Let's go ahead and go to the question and answer. Let me see if I can make that happen there. Could the forecoder bug be at all related to your in-comment calculator? I mean, certainly could. Long Boolean. Now that we are using this method to assign tags, does this change how you plan to organize lots of little items on a sheet that may have differing non-sheet wide tags? And in cases where using significance of positioning in the sprite sheet is too limiting, for example, maybe a collection of different fauna, each plant may have different tags for attributes, but cannot easily be put into categories. Yeah, we could just have a type that's like misc, and then we could just have it so that you have to specify a tag per panel or something, right? Yeah, so absolutely. I'd probably wait until I actually have that in front of me. So like when we do the cover, maybe if the cover works that way, kind of, you know, we can deal with that. What are some advanced parsing features that are interesting to you but may be too much work, not necessary for Handmade Hero? Parsing is not really advanced. Like what I wrote here is just all you need, really. I mean, that's pretty much it, right? One of the things that, you know, you would probably do if you were doing a more real thing, like something that wasn't just made for a simple game data file and you're trying to do, you know, something else. One thing you might do is, instead of just having a call called get token, you usually have peek token, so you can just look at a token or be able to go backwards and forwards in tokens, for example, so you don't just get them off the input stream, you can actually like move around. And the other thing is raw versus regular tokens. So when I do parsers for sort of more industrial strength use, typically what I'll do is there's one call which is called get raw token, and that literally produces the next thing that was seen in the input stream. So if it was white space, it'll say white space as a token that comes back. If it was a comment, it'll say comment, right? And then get token, as opposed to get token raw, will just keep calling get token raw until it sees a non-white space or comment result, right? That's really the only thing that you might do differently. And the reason for that is so that you can do things like write translation layers that preserve the comments and spacing of input things and only modifying the tokens they actually care about. Because you don't always just want to understand your input, you also sometimes want to preserve it in ways that are important. And the other thing that we will probably add this though, so I wouldn't say it's something that is advanced. It's probably something we'll just add, is tracking the line and column number. So that just for error reporting, right? So What is WNAT? Are there things that recursive descent is not good for, or does it cut it for them for most of the parsing stuff? I guess what I would say is recursive descent doesn't really work very well, and if you're talking about that alone, and you'll notice that like I didn't even do recursive descent, so we do a little bit of descent and we could have recursion if we wanted to, but you'll notice even I did loops and stuff in there, right? Technically, a recursive descent parser would not have loops and custom checking and stuff like that. It would always recurse to repeat, right? And so I think I would say recursive descent is not really good for anything other than recursively descending. It's one way that you structure a parser by hand for the parts of the parser that are conveniently done that way. Like, I want to parse an expression here, so I call parse expression. But don't parse the expression with recursive descent, because recursive descent sucks at parsing expressions, right? That's all. So things that are lists of things should be parsed with a simple list parser, right? What is your opinion of the Vulkan API and its future? I don't think it really has a future, except maybe as Android's default API, so maybe that's where that'll be. I've talked about it multiple times, so you can go look up in the search. Wasn't here for all of today's stream, but is require token what you'd use for look ahead? No. So for look ahead, so there's, okay. I mean, I guess I didn't mean to open up a Pandora's box of parsing questions. You know, I was just trying to say, let's have a text file that we can use, you know. So I was more just typing in the parser because I wanted to make sure that we had what we needed. I wasn't really trying to open the bigger topic of like, if you were going to write a compiler, you know, what should your parser look like? If you are doing look ahead, then there's two types of look ahead that you have to handle, and one is like way harder than the other. So the type of look ahead that's easy to handle is when the token types can't vary. So to give an example of that is, let's suppose that there's a rigorous definition of every type of thing that might get tokenized, and anything that is ambiguous grammatically can still be just represented by a token that then gets disambiguated later. And so the example would be like in C and C++, you can pretty much do this. I get a token, and yeah, technically the grammar wants to know something like, is this a type or is this an identifier? And you can't really know that without having more context to the system. But it doesn't really pose a problem for a fixed tokenizer because you can still just call that like an indeterminate name. And then further up the stream, when people are actually trying to resolve stuff, they can go ahead and change how they decided to parse, right? But the tokenizer doesn't have to care. So that kind of look ahead is easy to implement. The way I do it typically is I tokenize the whole darn file. And I actually just have the parser work on that, right? That way they can jump all around. They can look as many tokens ahead as they want. They can reverse back to previous tokens. They can do whatever they want. So I just tokenize the file, and then you operate on the tokens. Done. There's another kind of language, and I don't really know what an example is. Swift might have this. I can't remember. But if you define a language where things, directives in the language can change the token definition. So, let's say, for example, that I defined a language that doesn't have strings in it. So like quote a bunch of stuff and then quote isn't a thing, right? Well, if I tokenize something with that, then anything that appears like quote, author, quote, like what I'm looking at the screen right now, will appear as 3 tokens. Double quote is token 1, identifier author is token 2, and then double quote is token 3 again, right? But if inside that language I have the ability to describe using, I don't know, a regular expression or something, or some other definition, if I have the ability to describe how to create a token, and I add the ability to say, if you see a quote, take everything up till the next quote, no matter what it is 1 token. Now you can't do that, right? So basically, you have 2 different types of parser problem. One is where token, the act of determining what is and isn't a whole piece of text for tokenizing purposes, is able to be locked down at compile time of the language. Then that's really easy, just tokenize the entire file. If you don't have that and you have the ability to define in the language what's going on, then you've got it harder, and you have to make all kinds of concessions to that, as well as you'd better know what you're doing, because the language, if you're not careful, could have all kinds of ambiguities and like things where you have no idea, like what, things where the user can accidentally make totally indeterminate files that can't be parsed, or that you don't know if they're correct or not, or other things like that, right? All right, so I think that's everything for questions, hopefully. So I'm going to go ahead and bow out gracefully. As gracefully as I can ever really do. So let's go ahead and close this down. No complaints with how that went today. I would say that was great. We did exactly what we wanted, which is basically we made a parser for our file format, and we are good to go. So we can pretty much just start working with those files immediately when we return next weekend. So thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always go to handmadehero.org and press that pre-order button. It comes with the source code, so you can play around with it at home, and you can play around with your own parser designs if you'd like. That's about it for this weekend. I don't know that there'll be any streams this week, but I have already posted a schedule on the watch page. Unfortunately, the watch page is my stream live right now. But once that stream ends, it will pop back to the schedule so you can see when we're going to be live. Next weekend, same time, same place is pretty much the short answer. But if there are any updates, it'll show up on the watch page. You can also obviously subscribe on YouTube or Twitch for notifications and all that stuff, or check the Handmade Hero Twitter, all that stuff. Also, it's not subscribe on Twitch. Subscribe is for paying money. What is it? It's follow. You can also follow it on Twitch and set your notifications to on, and that'll just email you whenever we're live, so you can also get notified that way. That's it for this week. Have fun programming, everyone, over the coming week, and I will see everyone back here next weekend.